Oh, welcome to tutorials. Like and subscribe, share this video, and recommend us on any video you want us to solve next.
An auto transformer is supplied at 240 volts. Solution. An auto transformer is supplied at 240 volts. If the secondary is tapped to give 60 volts with a load current of 12 ampere, calculate the other two cycles current and show the direction of current and voltage. So now, an auto transformer is supplied at 240 volts. We have the voltage, which is what 240 volts. If the secondary is tapped to give 60 volts, that means this is for voltage 1, V1. So the secondary is tapped. So when the secondary is tapped, we have V2, and that is what 60 volts. Now, with a load current of 12 ampere, we have load current to be what? 12 ampere. Load current. To be equal to 12 ampere. Now calculate the two cycles current and show the direction of current and voltage. So the first thing we're going to do is we're going to write out the parameters. So after writing out the parameters, we're going to solve this. If I should make use of transformer ratio to solve this, I want to use transformer ratio to solve this. I will say transformer ratio which is also symbolized as K, is equals to V1 over V2 equals to N1 over N2 equals to I2 over I1. Now, why did we have I2, I1? Here we have V1, N1, V2, N2. Okay. There's a reason for it. If I should have V1, I1 equals to V2, I2. Okay. Now, if I should divide both sides by V2, this side divided by V2, here divided by V2. V2 here will cancel V2 here. Then we are no more with V2 here. Now we still have I1 here, is that not? So I divide both sides by I1 here. I1 here. This I1 here will cancel this I1 here. So we are left with no I1 here, no I1. So you can see V1, V2, I2, I1. That's the reason why we are having V1, V2, N1, N2, I2, I1. V1, V2 means voltage ratio. N1, N2 means number of turns ratio. I2, I1 means current ratio. Okay? So now what I'm going to be making use of here? We have voltage 240 volts and 60 volts, V1, V2. So we have that. But for current here is I2. So we're looking for what? We're looking for I1. Okay. Since our load current here is I2, which is what 12 ampere, we want to look for what? I1. So how do we solve? We have now V1 over V2 equals to I2 over I1. You might be wondering, why do we skip this? It's just like if I say this is equals to this equals to this. If I did not see this, I still know that this will be equals to what? This, since they are all the same. So since I'm only dealing with my V1, V2 now, V1 is what? 240 divided by what? 60 equals to I2 is what? Is 12 ampere divided by what? I1. So now, what am I going to do? I'll make I1 the solid of the formula. So making I1 is also solid of the formula. I have I1 to be equals to I1 times 240 and 12 times 60. We have 12 times 60. Is that not? And we have I1 times 240. That is 240 I1. If I divide both sides by 240, 240 here will cancel. The I1 will be equals to division of what? 240. 12 times 60 times over 240. Is that not? So 0 here will cancel 0 here. 12 here 1, 12 here 2. 2 here 1, 2 here 3. So I1 is equals to 3 ampere. Okay. So we are asked to show the direction of current, the direction. Okay. So now what they expect us to do before that, we have to look for our I3. In autotransformer, we have both I1, I2, and I3. So now I1 is equals to both I2 plus I3. But now we have I1 and we also have our load current, which is I2, but we don't have I3. So I make I3 the source of the formula. Now making I3 source of the formula, we have something like I3. This is I2. I2 will come here, then we are left with just only I3. So if I bring this there, I will have I1. Taking this to the other side will make it minus I2. Is what? We don't know. We are looking for it. Our current I3. But our current I1, we have it to be what? 3 ampere minus I2. I2 is what? I2 is 12. No? Okay, don't, just continue. I've made a mistake. 9 ampere. Now with this, I'm expected to draw a circuit showing the direction of current and voltage. Okay? So it will take this kind of form. The work of autotransformer is that you have to power smaller machines, smaller motors. So smaller loads. So we have it to, it's called 2 here. Then from here, we have a load here. The load is supplying 2. So this is our current I1, which is equal to 3 ampere. This is where our load current applies to I2, which is equal to 12 ampere. This is our load current. And from here, we have our 9 ampere, which is our 3. That is I3. I3 is here. So at this place, we have voltage 1, which is V1. And this V1 is 240 volts. At this point 2, we have V2. V2 going in this kind of direction. That is our voltage, our secondary voltage. Now at this point, it joins together. So with this diagram, we have been able to show our direction of current and voltage. I1 is going like this, I2 is going like this, I3 is going like this. So these are the